Video based upon permutations and combinations from the past papers of IGCSE 0606 additional mathematics. Coming to the first question from 2014, how many even numbers can less than 500 can be formed from 1, 2, 4, 5? So what are the numbers I have? 1, 2, 3, 4 and 5. So it has to be an even number less than 500. So it can be a 1-digit even number or 2-digit even number or a 3-digit even number. So 1-digit even numbers, how many are there? They are either 2 or 4. So therefore 2 ways. 2-digit even number, the last digit should be either 2 or 4. So it can be 2 ways. So if at all 2 is over, so how many numbers I am left over with? I am left over with 4 numbers. So 4 ways. 4 times 2, which is nothing but what? 8 ways or 8 numbers. Now 3-digit even number. So last one can be replaced with 2 or 4. So 2 ways. The first digit should be filled with either 1, 3 or 2 or 1, 3 or 4. So because 5 cannot take the first place, 100's place 5 cannot be there because it should be less than 500. So in either case it should be 3 ways. So for example, if 1 is over, so 2 was already over, so how many numbers are left over? 3 numbers are left over. So second digit can be filled in 3 ways. So totally it is 18 ways. So add all, there should be 28 ways. So total number of 5 numbers, even numbers which are less than 500 is 28. A committee of 8 people is to be chosen from 7 men and 5 women. There are 7 men and 5 women. Total how many I have to choose? 8 I have to choose. At least contain 3 men and 3 women. So I'm starting with 3 and 3. But 3 plus 3 is 6. So I want 8. So I'll make it as 5. Then I'll keep on decreasing this and increasing this. So 4, 4 and 5, 3. So what am I going to get there? 7C3. 7C3 times 5C5. 7C3 times 5C5 plus 7C4 times 5C4 plus 7C5 times 5C3. So this is going to be 35, and when I do by calculator, this is going to be 175 and this is going to be 210. Add them all, you are going to get 420. Now next part of the question, part 2. The oldest man or the oldest woman is in. So both but not both must be included. Means, what does it mean? Means, let me start a new page. Clearly we shall do. If that one man is out, then one woman should be in. If the man is out, the woman should be in. So there are man is out, there are 7 men. Out of that man is out means there will be only 6 men will be left over to be chosen from. So there are 5 men, 1 woman is already chosen. So there should be left over nothing but only 4 women to be choose from. Now 1 woman is already chosen. Here woman is already chosen. So remaining has to be becoming only 7 because this 7 plus 1 gives me 8. So I have to add it out, totally only 7 people. So now this is 6 and 1, maximum 6 and 1. Then keep on decreasing, this one decreasing and this one increasing. 5 and 2, then 4 and 3, then 3 and 4. So I reached 4. So that's all, these are only the ways. So for that, what does it becomes? 6C6 plus 4C1 times 4C1 plus 6C5 times 4C2 plus 6C4 times 4C3 plus 6C3 times 4C4. So this is going to be 4 plus 36 plus 60 plus 20. When I add all this, this is 120. This is 120 when the man is out. Man is out and woman is in. Now it will be the other way around also. Another 120 for man is in and woman is out. So totally it should be 120 plus 120, there should be 240 ways. That's going to be the answer for the first question. Now coming to the second question. Now we can see that second question is from 2012, November 2012, paper 21 and question number 9. So let's read the question. He says an art gallery displays 10 paintings in a row. Whenever in a row means obviously we are arranging them. When we are arranging them, it's going to be a permutation. So of these paintings, 5 are by Picasso, 4 are by Monet, and one is by Turner. And he is telling that find the number of different ways in the painting. Find the number of different ways in the painting can be displayed if there are no restrictions. There are no restrictions for this one. So he's asking us to find the different ways of painting. We can arrange them in an order. So let us see this one. How is that possible? So how many paintings are there? There are 10 paintings and we are supposed to arrange them in a row. So, and no restrictions at all. For no restrictions, what are we going to do? We are going to use the permutations concept. So let me write it out over here. 10 paintings. Picasso 5, Monet 4, and Turner is 1. 5, 4, 1. So I am doing 5, 4, and 1. So 10, 4, and 1. Let me check if it is connected or not. Okay. So I am going to take, there are no restrictions for this one. So I can find it out or arrange them all in an order. So I'm going to use permutations for this because we need not worry about any restrictions for this. So what am I going to do? I am going to find the permutations for this, which is 10 factorial. 10 factorial, which gives me 3628800. Find the different ways the paintings can be displayed if the paintings by each of the artists are kept together. So what am I doing it out? All Picassos as one bundle and all Monets by one bundle and TR is another bundle. So this can be arranged in 5 factorial ways. This can be arranged in 3 factorial ways. This can be arranged in 1 factorial way. So 5 factorial, 3 factorial, and 1 factorial. Now this is monets are 4, so therefore it's going to be 4 factorial, not 3 factorial. It's going to be 4 factorial. So totally, and again these 3 are 3 units. This is 1, 2, 3. These 3 are 3 units. These 3 units can be arranged in 3 factorial ways. So it is 5 factorial times 4 factorial times 1 factorial times 3 factorial. So it's going to be nothing but how much? 17280. B part. A committee of 4 senior students, 2 junior students is to be selected from a group of 6 senior and 5 junior. Senior are 6, junior are 5. What should I be doing it out? I should be selecting 4 senior and 2 junior. 4 senior and 2 junior. So I have to select it out 4 junior and 2 junior. So out of 6 I have to select 4. So it is going to be 6C4, which is going to be 15, and 5C2. 5C2 is nothing but how much? 10. 15 times 10, 150. That's the answer for the first part. Of the 6 senior students, is a cousin of one of the 5 junior students. Calculate the number of different committees which can be selected. At most one of the cousins is included. So one of the cousins is included. So therefore what should I be doing it out? I should be seeing that only one of the cousin is included. At least one of the cousin is included. At most, maximum. At most one of the cousin is included. So this 150 is all the ways of choosing the students. What are all the ways? Senior student is a cousin. One of the senior student is a cousin of the junior. So older cousin and younger cousin. Older cousin and younger cousin. So what are these all 150 ways? If older cousin is there, younger cousin is not there. If older cousin is not there, younger cousin is there, and both the cousins are not there. This all together is nothing but how much? 100, and both the cousins are there. This all together is 150. This all together is 150. When two cousins, one older cousin, senior cousin and junior cousin. If senior cousin is there, junior cousin should not be there, or else senior cousin is not there, yeah, junior cousin is there, or both the cousins are not there, or both the cousins are there. This together is nothing but what? 150. But now what is being asked in the question? He is asking that at most maximum only one should be there. Means it can be this way, it can be that both are not there, or only younger cousin is there, or only older cousin is there. So what should I be doing it out? The easiest way is 150 minus both the cousins are there. That should be the easiest way. So 150 minus, if I include both cousins, will be at most one cousin. At most one cousin. So I need to find it out how many ways both the cousins will be there. 150 minus both the cousins are there. So what should I be doing? Senior cousins. How many senior cousins are there? 6 and junior are 5. Senior are 6 and junior are 5. Both the cousins are there. So this 6 will become 5 and 5 will become 4. So now therefore I have only 5 senior cousins and 4 junior cousins. I'll write it out over here. I should be considering both the cousins. The case of both cousins present. 6 and 5. Senior, junior. Now I am selecting one senior, one junior. So 6 becomes 5, 5 becomes 4. So there will be now 5 senior cousins and 4 junior cousins. Now what should I be doing it out? But I have to select 4 and 2. But already out of 4, what it says, one is been selected, so three more. Out of two, one is more selected, so only one more. So it should be nothing but what? 5C3 times 4C1. 5C3 is 10 times 4C1 is 4, so 40 ways. These are the 40 ways when both the cousins are present. So 150 minus both are present. So 150 minus 40, which is 110. That's going to be the easiest way. That completes question number 2. Now coming to question number 3. This is from question number 3. So let's see that question. Arrangements of 5 different letters from the word amplitude are to be made. So we are making arrangements from 5 letters from the word amplitude are to be made, and find the number of 5-letter arrangements if there are no restrictions, and the number of 5-letter arrangements will start with A and end with E. Start with A and end with E. So how should I be able to do that kind of question? So let's start there, because these questions need to be dealt very carefully before solving it further. So we can see that this question is from again 2012 paper 11 of what it says June. So let's read the question carefully. He says that arrangements are made from the word amplitude. 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 And I have to make number of 5-letter arrangements if there are no restrictions at all. 5 letters. So totally how many are there? AMPLITUDE. So I think so when you count it out, there will be 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally there are 9 alphabets are there. Out of these 9 alphabets, I have to select 5. I have to select 5, and there are no restrictions at all. So out of 9, I have to select 5 and without any restrictions. So what should I be able to do that? It should be an easy question, because we are just selecting 9 out of 5, and are we arranging them? So we are doing it out arrangement. So whenever it is arrangement, it's going to be permutations. So out of 9, I am selecting 5, so 9p5, which is 15,120. The number of 5 arrangement which start with A and end with E. So part 2, they start with A and end with E. So A and E are over. So how many are left over now? 7 more are left over. Then out of that, I have to arrange only 3. So 7 alphabets. But how many places? 3 places. So it's going to be nothing but what? 7p3. 7p3 is nothing but how much? 210. Next, the tickets for a concert are given out randomly to a class of 20 students. No student is given more than 1 ticket. There are 15 tickets. Find the number of ways this can be done. So I am having 20 students. Out of two, I have to select only 15. So 20C15. This is selection, because we are not arranging. So only combination. So 15,504. That is B part 1. Now for part 2. There are 12 boys and 5 girls in the class. Find the number of ways in which 10 boys and 5 girls will get the tickets. Boys, girls, 12 boys, 8 girls. I have to choose 10 boys and 5 girls. So it's going to be 12C10 times 8C5. which is 3696. This is part 2. Coming to part 3. All the boys gets the tickets. All the boys will be getting the tickets. And how many tickets? Only 15 tickets. So boys are 12, girls are 8. So all boys are getting 12 boys are will be getting it on tickets. So therefore only 3 more. So because totally it should be what it says 15. So I am going to choose only 3 more girls. So 12C12, which is 1 times 8C3, which is going to be 56. Now coming to question number 4. So let's read the question number 4 carefully. So what does it says? 6-digit numbers are to be formed by using the digits 3, 4, 5, 6, 7 and 9. There is no 8 at all. 3, 4, 5, 6, 7 and 9. Then each digit may be used only once. There is no repetition at all. So in that case, what should I be doing it out? Find the number of 6-digit numbers that can be formed. So there is no repetition for this case. So I should be able to not repeat the numbers. So 6-digit number 1, 2, 3, 4, 5, 6. 6 digits are there. 1, 2, 3, 4, 5, 6 digits are there. And it has to be filling 6 places. So it can be done in 6 factorial ways, which is 720. Find the number of 6-digit numbers that are even. So I want a 6-digit number which is even. 1, 2, 3, 4, 5, 6. So even numbers is 4 and 6. The last digit can be either be 4 and 6. 4 comma 6. So this is nothing but what? 2 ways. Remaining 5 digits are left over. And how many places are left over? 5 places are left over. So it can be done in 5 factorial ways. So answer is 5 factorial times 2, which is going to be 240. Then greater than 500,000. The number of digits should be greater than 500,000. B, part 3. Greater than 500,000. 6-digit number 1, 2, 3, 4, 5, 6. And what are the numbers I have? 3, 4, 5, 6, 7 and 9. Greater than 500,000. So the first digit can be filled with 5, 6, 7, 9. So it can be filled with 4 ways. So remaining 5 digits are left over. Any 1 digit is over means what is this? For example, 7 is over. Remaining 5 digits are left over and 5 places are left over. So this entire thing can be done in 5 factorial ways. So 4 times 5 factorial, which is going to be 480. Then part 4, even and greater than 500,000. Part 4, even and greater than 500,000. So 1, 2, 3, 4, 5, 6. So over here even number and over here even number. That is one way. Another way is over here odd number and over here even number. These are the 2 ways of doing them. So if I write it out properly, neatly in a column, that it will be easy to understand. The first way will be 1, 2, 3, 4, 5, 6, and another one will be 1, 2, 3, 4, 5, 6. So here I have an even digit and an even digit, or else even digit and an odd digit. So even digit and an even digit. So once both even digits are over, so what are the numbers that I have? The numbers I have as 3, 4, 5, 6, 7, 9. I have 3, 4, 5, 6, 7, 9. There are only two even numbers. So if 4 goes over here, 6 goes over here. So I'm left over with 4 digits and 4 places. 4 digits and 4 places, it's going to be 4 factorial ways. 4 digits and 4 places, it's going to be 4 factorial ways. Now, if at all, I have an even number over here. So it can be either 4 or 6. And an odd number over here. It can be 3, 5. It cannot be 3. It can be 5, 7, 5, 7, 9. Odd numbers are 5, 7, 9 because I want a greater than 500,000. So it should be starting either with 5, 6 cannot start because it is not an even number. It's not an odd number. So 5, 7, 9. So what should I be doing it out for this one now? So let's try it out carefully over here. This will be 4 times 4 factorial. Why 4 times 4 factorial? 4 digits are left over and 4 places are there. 4 digits, 4 places can be done in 4 factorial, and again the remaining is nothing but what? 4. So 4 times 4 factorial. So totally this is 24 and this is 144. 24 plus 144, which is 168. That's going to be the answer for this even and greater than 500,000. There are 164, 168 ways of doing this kind of numbers, which using 3, 4, 5, 6, 7 and 9. This one, once again, let me explain it out over here. How is that 4 times 4 factorial? Because I know I would have went very fast. So if I would have used 4, then the numbers will be 6, 5, 7, 9. If at all I would have used 6, then it would have been 4, what is this number. If at all I would have used 6, then again I would have had 4 ways over here. So 4 times and remaining 4 digits and 4 places. 4 digits in 4 places is 4 factorial. If at all I used 4, then I will be having 4 digits, 6, 5, 7, 9. Then 6, 5, 7, 9 is 4 digits, so it can be written as 4 times 4 ways, and remaining 4 digits are there and 4 places. That's going to be the answer. So 24 plus 144. Over here I cannot take 4 and 6. Why? Because it will be less than 500,000. So I have to take only 6 and 4. So there is only one way. So once I redo this one, because I know this is somewhat confusing for many people. So 3, 4, 5, 6, 7, 9. 3, 4, 5, 6, 7, 9. I have to make an even number and greater than 500,000. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Why I have taken? This can be an even number, the last digit is even number, or the first digit is odd and the last digit is even. Now the last digit is even, so it can be 4 and 6. There is only one way. I cannot take 4 and 6 over here because it will become 400,000. So therefore this combination is not possible. Only 6 and 4. 6 should be in the first place and 4 should be in the last place. So I am left over with, if 6 and 4 are over, I am left over with 4 digits, and it should be filling 4 places. 4 digits in 4 places can be done in 4 factorial ways, which is 24. Coming to this one, even numbers. What are the even numbers? 4 and 6 are the even numbers. If already 4 is used, then I have 6. What do I have? I have 3, 5, 6, 7. So how many ways are there? 4 ways are there. 4 ways are there over there. Now, so that is 4 times. I cannot use 6 and I cannot use 4 because it may become 400,000. So that option is not possible. So therefore, is only one way. Then again, 4 digits are left over because 2 digits are used and 4 places are left. So 4 digits in 4 places can be done in 4 times 4 factorial. So 24 plus 144 is going to be the answer, which is 168. That is the answer for the question. Now coming to question number 5. So this question number 5 is from 2011. Question number 21, paper number 21, question number 6 of June 2011. So let us do that one now. June 2011, question paper 21, question number 6. A shelf contains 8 different travel books, of which 5 are Europe and 3 are about Africa. 5 are about Europe and 3 are about Africa. So Europe is 5. Africa is 3. Find the number of ways that can be arranged if there are no restrictions at all. So 8 factorial. 8 factorial is nothing but what? 40320. This is part 1. Find the number of ways it can be arranged. 5 books about Europe are kept together. 5 books about Europe are kept together. So all these 5 books of Europe is one bundle. That is one unit. And Africa are 3 units. So totally how many units I have? 4 units. 4 units can be arranged in how many ways? 4 factorial ways. And this 5 Europe can be arranged in nothing but how much? 5 factorial ways. So 5 factorial times 4 factorial, which is 120 times 24, which is 2880. Part B. 3 DVDs and 2 videotapes are to be selected from 7 DVDs and 5 videotapes. DVD 7, videotapes 5. And how many I have to select it out? 3 and 2. 3, 2. So, and calculate the number of different selections can be done. Selections. So 7C3 times 5C2, which is going to be 35 times 10, which is 350. That was a comparatively easy question. Now coming to the next question, question number 6. So there are 10 questions in this. We have done 5 questions. Now I'm going to the 6th question. This is from November 2010 and paper 21, question number 6. Now, so let's read. A 4-digit number is to be formed by using the digits 1, 3, 4, 5, 7, 8 and 9. Then no digit can be used more than once. 4-digit number. No restrictions. 1, 2, 3, 4. So first one can be filled in. How many numbers are there? 1, 2, 3, 4, 5, 6, 7. 7 ways. The second one can be filled in 6 ways. Next one can be filled in 5 ways. And the next one can be filled in 4 ways. So 7 times, 6 times, 5 times, 4. So it's going to be 840. The number is less than 4000. 2, 3, 4. So what is the number? Should be less than 4000. Less than 4000 means The first digit can be either 1 or 3. So there are only two ways. If 1 is over, so how many digits are left over? 6 digits are left over. So 6 ways. And this one is, I move them. The remaining one digit is over means it can be filled in 5 ways. Then this can be filled in 4 ways. So it is 2 times 6 times 5 times 4, which is nothing but what? 240. The number is even and less than 4000. The number is even and less than 4000. So even number. So this place can be filled in 1 and 3. So it is nothing but what? 2 ways. 1 and 3. So it is 2 ways. Now the last digit should be filled with 4 and 8. There are only two even numbers. So 4 and 8. So again it can be filled in 2 ways. So 2 digits are over. In 1, 3, 1, 3, 4, 5, 7, 8, 9. 1, 3, 4, 5, 7, 8, 9. Any two digits are over. For example, 1 and 4 are over. So 1 and 4 are over. So how many are left over? 1, 2, 3, 4, 5. So this can be filled in 5 ways. One more digit is over. This can be filled in 4 ways. So answer is going to be 2 times 5 times 4 times 2, which is going to be 80. That is question number 6. Now coming to question number 7. So this time this question is from March and 2015, paper 22, question number 2. So question number 2 means it should be comparatively a easy question. Sean has 9 different flags. Find the number of different ways in which Sean can choose 3 flags from her 9 flags. So she is choosing 3 flags from 9 flags. So it is just nothing but what? 9C3. It is 84. Sean has 5 flagpoles in a row means permutation. She puts one of her 9 flags on each flagpole. Calculate the number of different 5 flags arrangements she can do. Now it is arrangement, so 9C5, which is going to be 15120. Next part, that was part 2. Part B, the 6-digit number 738925 are rearranged so that the resulting digits must be an even. Find the number of ways in which this can be done. Number of ways this can be done. 6-digit number. 1, 2, 3, 4, 5, 6. What are the numbers I have? The numbers I have are, if at all I write in order, 2, 3, 5, 7, 8, 9. So the last number should be nothing but what? An even number. So there is only one even number 2, so one way. So how many are left over? 5 digits. 5 digits are left over and 5 places are left over. 5 digits at 5 places can be done in how many ways? 5 factorial ways. Then, so that is 5 factorial. And do I have any another even number? Yes. If at all I choose 8 as another even number, then again 5 digits are left over and 5 places are there. So this is again another 5 factorial. So total answer is 5 factorial plus 5 factorial, which is nothing but how much? 240. Or else another easiest way is last digit can be filled in 2 and 8, so which is 2 ways. And remaining 5 can be filled in 5 factorial ways. So 5 factorial times 2 is nothing but what? 240. You are going to get the same answer. Question number 8. So this question is from June 2015, paper 21, question number 5. A lock can be opened using only the number 4351. State whether this is a permutation or combination of digits, giving your answer. So, because it is an order, if at all a specific order is allowed, so it's going to be permutation. A specific order, therefore permutation. There are 20 numbered balls in a bag. 2 of the balls are numbered 0, 6 are numbered 1, 5 are numbered 2, and 7 are numbered 3 as shown in the table below. 4 of these balls are chosen at random without replacement. Calculate the number of ways this can be done so that 4 balls are having the same number. 4 balls have the same number. Now, number of balls is 0. What is it telling? There are 20 numbered balls in the bag. So total number of balls is nothing but what? Total number of balls equals to 20. 2 are numbered 0. 6 balls are numbered 1. 5 balls are numbered 2. And 7 balls are numbered 3. So to make it to understand, I just write it out. It's not required. So 2 balls are numbered 0. So 0, comma 0. 6 balls are numbered 1, 1, 1, 1, 1, 1, and 1. Then 5 are numbered 2, 2, 2. 7 are numbered 3, 3, 3, 3, 3, 3, 3, and 3. So I have it out this kind of selection. Now 4 balls of these two are to be chosen without replacement. Calculate the number of ways this can be done that the 4 balls all have the same number. So they should be having the same number. So what should be the way of choosing it out? 4 balls so that they have the same number. And 2 are having 5. So I have to move this one over here, and there are 2, 2, and 2. So I can choose from what is this? From here, I can choose from here, I can choose from here. So out of 6, I have to choose any 4, or means plus. Out of this 5, I have to choose any 4, or plus. Out of this, let me draw a line. It will be much more easy. Out of this 7, I have to choose any 4. So 7C4, 6C4 plus 5C4 plus 7C4. So total is going to be nothing but how much? 25. 55. The 4 balls are having different numbers. This time the 4 balls are having the different numbers. So the same thing, I just make it out. 1, 1, 1, 1, and 1. How many times are there? This is 6 times, 5 times, 7 times, 6 times, then 5 times, and 7 times. So 1 ball from here, so it's going to be 2C1. 1 ball from here, 6C1. 1 ball from here, which is 5C1. And 1 ball from here, which is 7C1. So add them all, because first ball and, second ball and, third ball and means multiplication, or means addition. So this is going to be 420. The 4 balls have a total of 3. Total of 3. The 4 ball, first ball, second ball, total of 3, no, total of 3, yes. Third ball and the fourth ball. When they add it up, it should be becoming 3. So when I add all the 4 balls, it should be 3. So first ball is numbered 0, second ball is numbered 1, third ball is numbered 2, and fourth ball is numbered 3. For our convenience, I'm doing it out like that. What are the combinations which gives me 3? So if at all I select it out over here, this gives me 3, 0, what is this? I choose from 0, I choose from 1, and I choose from 2. So if I choose, very carefully this has to be done, because my total of all the balls should be 3. And here also I write how many are there. There are 2 such balls, there are 6 such balls, there are 5, and there are 7. So I cannot choose 3, because if at all I choose 3, because the sum is only 3, so I cannot choose 3. 3 cannot be one of the balls, so it has to be only from the combination of 0, 1, 2. It cannot be 3 at all. If at all it is 0, 1, 2, I am taking 2 balls from here, so which is 0 plus 0. Then 1 ball from here, which is 1, and 1 ball from here, which is 2, which gives me 3. Which gives me 3. That is one of the way. This is one of the way. 2 balls, 1 ball, and 1 ball. Then I decrease it further. So keep on decreasing 1. So I'll be taking it out 1 ball from here, 1 ball from the 0. So still I have to select it out 3 more balls. 3 more balls. Those 3 balls should be from 1 itself only, because this is 0 plus 1 plus 1 plus 1. This will give me nothing but what? 3. This is another selection. That's all. These are the only 2 selections. So for the first one, answer should be 2C2 times 6C1 times 5C1. 2C2, 6C1, 5C1. And or another way is nothing but what? 2C1 times 6C3. Do it out by calculator. It should be giving you 70. This is a very tricky question. Pause the video, do it very slowly, and then do that. You should be able to get that answer. So or else, let me do that once again, because I have the balls with the number 0, 1, 2, and 3. How many balls are there? Such balls? 2 balls are there, 5 balls are there, 6 balls are there, and 7 balls are there. 2, have I written correct? 2, 6, 5, 7. 6 and 5 are swapped. 6 balls here, 5 balls here. The total of the balls should be nothing but how much? 3. So, but the ball cannot be 3, because I have to select total should be 3. So, one of the ball cannot be 3. So, I'll go for maximum. I'll select 1 ball, 2 balls from here. Then 1 ball from here. If at all I select 2 balls from here, which is 0 plus 0. 1 ball from here, which is 1. And 1 ball from here, which is again 2. So, which gives me 3. So, this is one combination. Then another combination is going to be nothing but 1 ball from here, and if at all I select 1 and 1, so there will be only 3 balls, but I have to select 4 balls, so therefore I'll select it out all the remaining 3 balls from here and 0 balls from here. So this is 0, all the 3 balls, 1 plus 1 plus 1. This gives me 3. So this is another combination. So what are the combinations that I have? Which is 2C2 times 5C1 times 6C1. Another combination is 2C1 times 6C3, which is going to be 70. Now coming to question number 9. This is from November 2015. Question number 11, paper 11, question number 4. 6 books are to be chosen at random from 5 different books. Find the number of different selections of 6 books that could be made. So, selection of 6 books from 8 books. So, it is very simple one. A part 1, 8C6. 8C6 is going to be 28. A clock is displayed on the shelf with 3 of the 8 different books on each side of it. Find the number of ways which can be done if there are no restrictions of the books. A clock is to be displayed. There is a clock, and he says that on the shelf with three books of the eight books on each side. Three books over here and three books over here. He has to select it out. Three books and three books. Then find the number of ways it can be done. If there are no, what it says, restrictions for the choosing of the books. So what should I be doing it out? I have to select three books from here, three books from there, and in between a clock and eight different books. And now what it says, find the number of ways it can be done. So it's nothing but what it is, permutations or combinations you need to understand. So because we are arranging them, we are arranging it out. So the final answer, see, we have to choose six books. So let's do this one very carefully. What he says, a clock to be displayed on the shelf. There is a clock. I draw a clock over here in the shelf with three books of the eight different books on each side of it. So book 1, book 2, book 3, and there should be book 4, book 5, and book 6. All six are three different books. So what am I doing it at? I am selecting three books. First of all, I am selecting three books from the eight. Then I will be left over with five books from the eight. So first of all, if at all I select these three books from eight, so it should be 8p3. So three books are over out of eight books. Three books are over, so five books are left over. Still, I have to select three more. So 5p3. 8p3 times 5p3 is 20,160. Three of the books are music books, which have to be kept together. Three of the eight books are music books, which are to be kept together. So therefore, B1, B2, B3, B4, B5, M1, M2, M3. These all, what is this? There are three music books. This all three music books should be, what is this, together. What should be done? So three music books together every time. These all are one bundle. M1, M2, M3. They should be always together. How it should be solved. So we need to be very much carefully understanding. So let's add a page and carefully understand this question. This is a shelf. So M1, M2, M3 should be here, or else M1, M2, M3 should be here. So remaining five books, B1, B2, B3, B4, B5. Three should be going over here. Three books should be going over here. So this is done in 3 factorial ways, and out of 5, 3 can be arranged in 5p3 ways, which is nothing but what, 360. Similarly, over here also it should be 5p3 times, this is 3 factorial. So 5p3 times 3 factorial, which is 360. So 360 plus 360, which is 720. A team of 6 tennis players is to be chosen from 10 tennis players consisting of 7 women, 7 men, and 3 women. 7 men and 3 women. Again, and add a page. Men are 7, women are 3. Then find the number of different teams that can be chosen if the team must be included at least one woman. At least one woman. One woman, and total should be nothing but how much? 6. So 1 5 2 4 3 3. So it's going to be 7C5 times 3C1 plus 7C4 times 3C2 plus 7C3 times 3C3, which is 63 plus 105 plus 35, which is going to be 203. Now coming to question number 10. This is from March 2016, paper 12. Paper 12, question number 5. A 6-character password is to be chosen. From the 9 characters, letters A, B, C, E, F, and 5, 8, 9, and star and dollar symbol. Each character may be used only once. Find the number of different 6-character words if chosen if there are no restrictions. So no restrictions, it's just going to be 9p6, which is 60,480. The password must contain 2 letters, 2 numbers, and 2 symbols. 2 letters, 4p2, 2, then 2 numbers, 3p2, and 2 symbols, as there are only 2. So therefore, multiply them all, 144. Then password must start and finish with a symbol. And how many digit symbol is that? 6-digit symbol. 1, 2, 3, 4, 5, 6. Start and fill with it. So it can be a dollar and an asterisk, or a dollar and an asterisk over here. So there are 2 ways, 2 times. Now remaining, what is the thing? There are 4 digits are there. There are, how many are there? If this symbols are over, 1, 1, 2, 3, 4, 5, 6, 7. 7 are there. So, and 7 options are there, but only 4 places. It can be done in 7p4. So 2 times 7p4, which is 2 times 840, which is 1680. Part B, an examination consists of section A containing 10 short questions, section B 5 long questions. So short questions 10, long questions 5. Then candidate is required to answer 6 questions from section A and 3 questions from section B. Find the number of ways if there is no restriction at all. 6 and 3. So it can be written as 10c6 times 5c3, which is 2100. Candidate must answer first 2 questions in section A and first question in section B. First 2 questions in section A. So 2 questions are already answered. This will become 8 and this will become 4. So 8c4 times, and 1 question from here. So this will become 4 and this will become 2. 4c2. So which is going to be nothing but what? 420. So that completes this video for covering all the past paper questions based on the topic permutations and combinations. See you in the next video. Bye.